Suppose we have 7 students, but only 3 chairs available. And we want to choose 3 students and arrange them in the chairs. So in this case, the order matters. And what we mean by that, of course, is if Alice sits in the first chair and Bob sits in the second chair, that is different for us than if Bob sits in the first chair and Alice sits in the second chair. So let's count all the possibilities. So let's put the options here for the chairs. So this will be the first chair, this will be the second chair, and this will be the third chair. So how many options do we have for the first chair? So we have 7 options for the first chair. So there are 7 students to pick from. Now, after one student is chosen, there are 6 students left. So for the second chair, we have 6 choices. And then, of course, after that, there are only 5 students left. So then for the third chair, we have 5 choices. And so if you then multiply these, you'll get 210, which is the answer to our question. So in how many ways can we seat the students? In 210 ways. And so this kind of counting problem is called a permutation. And so permutation is an ordered arrangement of objects. And so here we're choosing 3 students out of 7, right? Now, we can actually relate this to factorials in the following way. Notice that we can write 7. So if we do 7 factorial, it's equal to 7 times 6 times 5, right? Times 4 times 3 times 2 times 1, let's say. And this part here is 4 factorial. So this is just 7 times 6 times 5 times 4 factorial. And so if you pass the 4 factorial dividing, you'll get that 7 factorial divided by 4 factorial is equal to 7 times 6 times 5. And that means that this formula on top here is actually the same as 7 factorial divided by 4 factorial. And this will be true in general. So it will be true in general that the number of ways to arrange or permute our items chosen from a set of n distinct items is going to be given by n factorial over n minus r factorial. Now, why is that the case? Why does this formula make sense? So the idea is that the numerator here, the n factorial, it counts all the arrangements of n objects. But since you're only interested in the first r positions, you cancel out the n minus r factorial from the arrangements of the objects that you didn't choose. So again, in our example, since we're only interested in 3 objects, you can think of this as permuting all the 7 objects, but you only care about the first 3, so you get rid of the last 4 here, and that's why you divide by this here. And of course, if you arrange all the items, so if you choose all of them, then the n minus n here cancels out, and you just get that it's n factorial, which again is the amount of ways that you can permute n objects. So the main idea here is that we use permutations when we are selecting objects and the order matters.